Dear ladies and gentlemen, welcome back to Asia Conference Day of the 5th Transport and Climate Change Week. The agenda for the afternoon session are packed with a variety of interesting content, and we hope you stay tuned until the end. For the next session, we will take a glimpse into the topic of eMobilities, especially on charging infrastructure in ASEAN countries. Please welcome our moderator, Mr. Stephen Draxler, Technical Advisor for NDC Transport Initiative for Asia. Stephen, are you with us?
Yes, I am, Khun Pan. Can you hear me?
Yes, loud and clear, Kap. So now, let me hand it over to you, Kap Stephen. I hope you're ready. The floor is yours.
I am ready, yes. Thank you very much for the introduction. So I will just briefly share my screen. So welcome back, dear viewers, also from my side. My name is Stephen, and I'm delighted that you're joining our session on eMobility EV charging infrastructure today. What we'll be doing is we'll be giving you a dive into this world, and we'll be looking at several different areas. So of course, we've only got 1 hour today, and EV charging infrastructure isn't as simple as some people might think. So what we really want to do is show you some hot topics and really trigger your appetite for this complex area. And for this, we've got 5 exciting speakers on board from 5 different Asian countries who will be giving glimpse into 5 different work areas. So we'll be starting off with eMobility roadmap, so rather overarching topic, which where we are happy to have Professor Anh Tuan on board. He's running a bit late, so we'll put him further towards the back, but he'll give us an interesting overview over the current topics in Vietnam. Then we'll go over to another area, which is infrastructure. So we'll dive a bit deeper on several infrastructure types. So first we'll start off with e-bus charging infrastructure. There we're delighted to have Mr.Yoga Adiwinarto on board. He's an Operation and Safety Director at Transjakarta in Indonesia. After this, we'll be moving very rapidly into the battery swapping world, where we'll have Dr. Pimpa Limthongkul, a research team leader from Testa in Thailand. We'll be talking about light vehicles, battery swapping for light vehicles, followed by the heavy vehicles. So battery swapping also has reached heavy-duty vehicles. And for this, we've got Mr.Hu Jinyong from the Center for Vehicle Electrification of the China Society of Automotive Engineers. And this will kind of wrap up our infrastructure part of today's session. And finally, we'll be addressing the big link which will happen between the sectors of transport and energy, which is all about grid integration and the use of renewable energy. And for this, we'll have Professor Zakir Husssain from, professor, of course, at the Department of Energy Science and Engineering at IIT Bombay in India. So as you see, a lot of topics to move through, and not that much time, but we'll have short spotlight presentations on the topics, and then we'll have time to discuss a couple of questions. So you have to understand that we won't be able to address every question from the chat, as we've got some questions from our side as well to frame the topic a bit better, but without wanting to take too much time out of the topics, I think we'll just go ahead and start. And I think, if I've heard correctly, Professor Tuan isn't on stage yet. So I think we'll, maybe you could confirm this, Khun Pan. If this is the case, I'll move on to Mr. Yoga Adiwinarto, if that's okay. I'll take that as an okay. Great. So Mr. Yoga Adiwinarto, I'm happy to share your slides. for you. Please just let me know if everything is ready. I'm just running into. Hey, hi. So, Mr. Chandra, are you happy to take over from Mr. Adiwinarto?
Yeah, Mr. Yoga,
Great.
sorry, cannot join because he have overseas trip, so I replace him.
No problem. No problem. I'm just making sure to share your presentation. Let me know if you can see it, and then we can take it from there. Great. That's visible. Maybe you can go on full screen. Yeah, perfect. Thanks. So go ahead.
Thanks. Yeah, thank you. Sorry for my lately. I would like to present that our charging infrastructure that will be operated in this month. Yeah, this is the background that why Indonesia go to the electrification, because the presidential decree already issued in 2019, and then some of the ministerial decree already issued. I would like to show here is about the price of the electricity. Government give the incentive for three items about the cost of the electricity. Number 1 and 2 is about the installment fee that can pay for the 24 months depreciation, and then no obligation for the minimum account fee. But here the price of electric is around 50% from the regular price. This is the special price that the government give for the electrification. And then this is for the provincial government commitment that Jakarta have a target to get the zero emission in 2050. And previously, our governor in 2019 also already give a commitment to C40 to electrify the transportation from 2025. Government only procure the zero emission buses. And here our planning for the electrification, the objective is get to 100% of our bus become electric bus in 2030, and the number is around 10,000 buses. And we are in this year we starting to procure 70 buses. It is around 2% from our currently fleet number. And starting from this year, we already procured 30 buses. Some of buses already starting operating for March, and later on will be operate in this month, because now we still prepare the charging. 30 buses will be supported by 10 charger. We use overnight operation will be overnight charging with the capacity is 200 kilowatt charging. The estimation around 1.5 until 2 hours for the fully charging. We prepare now. We provide 2 megawatt electricity, and step down is using 3 trafo, and then for the panel we use this is provided by local contractor, and then from this 2 megawatt will supply to our 10 charger. Currently we plan to use 3 charger is with the ratio is 1/3 buses. Maybe in later operation this will be added the bus to optimize the number of charger. This is the operation plan that we have now. The bus will be charging 100% capacity in 4 a.m. and then starting operation in 5 a.m. Then will be go back to the depot in 11. So the operator have around 5 hours to prepare the battery with a fully capacity. And the mileage is around 196 kilo per day. That currently the charging time is around 1.5 with the maximum capacity. This is the local vendor that now provide both of the infrastructure and the charger. And yeah, we use a three trafo step down, and then the charger itself, even it is made by local vendor but already certified by BYD China, so we can sure about the performance. And also the standard that charging use already follow the international standard. And why we use the local vendor is we can get the lower price, and also if we use the local vendor, we can get a good connection from him with our electricity vendor, national electricity vendor is PLN. So also we can ensure the maintenance and repair. This is the challenge that we have, we will facing during our first operation of the buses. The charging is now still huge, or large investment or huge investment even for Transjakarta or for operator. And we plan not only build the overnight charging, but we also have to prepare the opportunity charging in the route, because some of the type of bus cannot operate only by overnight, but they also have to support by opportunity charging in terms of the weight, because the battery weight is because the mileage of daily mileage is need the big capacity battery. And then for the electricity supply itself from our government, this is also still a question for us, whether we can go with the 10,000 electric bus, whether the electricity enough or not in the future. This is the homework that we still have to discuss with the electricity supply. And also in other side is this is the new technology that need information system reliability, because the accuracy of the charging time is really important for the operator, because they only have a 5 hour, not only for charging but also for repair and others. That's all information from us. Thank you. Back to you, Stephen.
Great. Thanks, Chandra, for jumping in. Interesting and very detailed presentation on your charging network for e-buses. We will take a couple of questions later on, but for now, we'll take a step back again to our first agenda point, which will be the eMobility roadmaps by Professor Tuan, who now has reached our studio. So I will go ahead and share your presentation, Professor Tuan. No, you've already done it. Great. Even better. So without wasting further time, I'll just hand over to you.
Okay. So my voice is already clear, right? First of all, I would like to thank for the invitation, so that I have a time to be here in this studio. I will talk very short about the charging station roadmap and the power circuit system for electric vehicle development. Take a look on the right figures. We can see that there are three mode of charging technologies. It is conductive, either on board or off board, and the wireless, inductive or capacitive, and the battery swapping. And if we take a look on the left hand side, we can see there are two types of onboard chargers, AC chargers and DC chargers on the right side for the off-board charger. Let's say that with a fast charging station, a huge required power demand affects strongly on the grid, especially in the developing country, where the grid is not designed for fast charging station. So therefore, we have to adapt, the fast charging station to our power grid. It is very important for the electric vehicle development. And a case of Vietnam, I would say that it is in a very, very early stage of the electric vehicle development. So only a few private companies participated. And for electric wheelers, only VinFast is the leading company. And for electric two-wheelers, VinFast and MBI are the two providers for the electric vehicles, including the charging infrastructure. And on the right side, the picture on the right side of my slide, you can see that some picture we took from the VinFast charging station, and VinFast plans to build 2,000 charging stations with over 40,000 charging connections for electric two-wheelers and electric four-wheeler in 2021. But let's say that due to a lot of obstacles, including COVID-19 pandemics, so they developed a little bit slower than what they wished. And there are two types of charging stations developed by VinFast for four-wheelers, electric four-wheelers, including 30 kilowatt charging station and 60 kilowatt DC fast charger. And when we talk about the electric vehicle development, we have to take care of the existing grid, power grid of Vietnam. And on the left side of the slide, you can see the energy production and peak load from 2015 to 2030, and also the install capacity and peak load. Take a look on the table on the right side. You can see that the backup capacity is forecasted for the total install capacity and peak load is around 40 to 45%, which is enable for electric vehicle development. But of course, the long-term electricity load remains high, with the average growth rate of about 10.7% per year over the past 10 years. And in the next year, the developing the growth rate would be even more than that. And there are a lot of lessons that we can learn from different countries about the impact of charging station on the grid. And there are two phases in the complete charging cycles. The first would be constant current from 0 to almost 80% of the charge state, and then come up with constant volume, follow until full charges. And during this process, a waveform distortion in the supply voltage would be created due to electric vehicle developments. And there is some assumption in case that all car of the UK is changed to electric vehicle, and what happens? On the left side, we can see that if this electric vehicle charges at the same time at the 7 kilowatt typical home charger rate, and the total power required will be 229 gigawatt, which is 3 times higher than current grid capacities. And another case on the right side, if all electric vehicles are charged at the same time at 50 kilowatt hour, it is a type of common public DC charger rate, and the total required power will be 1.6 terawatt, which is 21.5 times more than current grid capacity. And therefore, it is very important to improve and manage the electric vehicle charging station. In order to develop a charging roadmap on the national and a city level for Vietnam, please move to the next slide. And I would say that we must go through 4 steps. The first, to build EV portal to support the government and to manage the related issue on EV transport, and to provide all information related to electric vehicles, and to create the master plan for electric vehicle charging station by calculating the demand as well as using the current grid systems. And finally, to register to allocate new electric vehicle charging station. So a portal for electric vehicle in Vietnam must be established in the near future. And it is my final slide. If we manage to establish the EV portal and the EV application, like the app for mobile phone, for example, and from the government, we can control and add the charging station, see the performance of the station, plan for EV charging station in city or national level. And for users, it is also very important after registering, the charging station will be connected to the application. User can know the location, status, booking, payment, get direction to the charging station, and vote for the services, for example. Okay, due to the limited time, so let's say that thank you very much for your attention.
Great. Thank you very much, Professor Tuan, for your interesting presentation. I'll just go back to the slide for 1 second. I hope everyone can see it. As we had to reschedule a bit, of course. We've heard Professor Tuan right now highlight the importance of eMobility roadmaps, and also had the deep dive from Chandra from Transjakarta, showing one example of EV charging infrastructure implementation. What we want to do now is move further with technology, infrastructure technology, and that will be battery swapping. So we'll start or continue with Dr. Pimpa Limthongkul on battery swapping for 2- and 3-wheelers. So Dr. Pimpa, I will make sure to share your slide.
Hello. I guess good morning, good evening, good afternoon, everyone. My name is, can you hear me well?
Yes, we can.
Okay. My name is Pimpa Limthongkul, and I'm at National Energy Technology Center, National Science and Development Agency, Thailand, which is a national lab in Thailand. Today, I will be speaking on the topic that will be related to the future of e-mobilities, specifically on the 2-wheelers, because we are working on the project on the Thailand battery swapping platform. So next slide, please. So as everyone or a lot of you might have heard about the Thailand EV policy towards the 30-30 policy, which is the 30% EV production in 2030, both on the cars, motorbikes, buses, and also having to work on the infrastructure. Next slide. For the electric mobility on the motorcycle side, which in Thailand, we have over 20 million e-motorcycles. The target on the government is to have the 675,000 e-bikes production by 2030 and 650,000 for the local use. And with that, it will need the 1450 swapping station. With this goal in mind, a lot of efforts have been done in order to reach the goal that will be set that has been set to 2030. Next slide, please. So regarding this e-motorcycle usage, the current status is that a lot of people have been using it in the daily life, but the other objective of using the e-motorcycles or the purpose is to use it for other purposes such as the e-delivery, like parcel delivery and food delivery, which is becoming very popular in Thailand. So with that, the current spec of the batteries in the e-motorcycle require long charging time because it needs basically the traveling distance for these e-bikes are in the average of the 200 kilometers per day. With that, you will need a large batteries in order to travel the whole day without charging. But the current spec of the battery use quite a long charging time, which is not suitable for this type of purpose of the application. So that cannot satisfy the demand for the traveling distance of this application. So with that, the solution is the option one is to whether the batteries can be have a fast charging property. So that will have to be done with the battery development, which is being done in parallel all over the world, right? The other is to have the option of battery swapping, which is swappable battery within the same operator, which we have actually had some the operator operating right now, like Swap and Go, and also E-Tran and HSEM, and Honda is also started implementing some of the trial in Thailand. And also Electric Generating Authority of Thailand also have this type of battery swapping. But those are within the same operator, which means that they own the motorbikes, they own the charging station, and they own the battery themselves and not being used across. Option 3 is what we are talking about today, is having the national swapping standard platform, which means that the batteries can be swapped within and with across operating operator, meaning that you can swap batteries within with across the motorcycle, different motorcycle brand or motorcycle models, and also can charge at different charging stations operated by different operators. So this project is the Thailand Battery Swapping Platform. The project period has been started from the end of last year, and the trial will be running and finish at the beginning of next year in 2023. Next slide, please. So this project is a collaborative project between Research Institute, which is my institute. It's a National Science and Technology Development Agency, university, KMUTT, and Khon Kaen University, and also battery pack producer, Beta Energy Solution, e-motorcycle producers in Thailand, GPX, and also iMotor, and also charging service provider, which includes an Electric Generating Authority of Thailand, Gridwitz, Bang Jak, and also Beta Energy Solution. So there are about 9 organizations that are working together in this collaborative project, which we hope that we can actually have a trial on having a national battery swapping platform for our country, so that infrastructure of like swapping station, charging station, and also a lot of part production can be done, which will be more economic. So this is to target to create standardized battery packs, which can be used in various motorcycle providers and charging operators. This project is basically being supported by the Program Management Unit Competitiveness by the Ministry of Higher Education, Science, Research, and Innovation. Next slide, please. So with this, this collaboration is not, we cannot do it alone. We have to work closely with also the standardized authority, like the Thai Industrial Standard Institute. And they have actually initiated this battery swapping standards already, but we are refining this with this project. The project is being done towards the goal of sharing the knowledge with going towards the sharing economy, and also to provide cost reduction and sustainability of the battery and also motorcycle two-wheelers, and also all the infrastructures that being developed and also used here. You can follow us at batteryswapping.in.th for further information, and you can also give us inputs and feedbacks on what shall be done or what could be done, as we are hoping that having and sharing all these technologies are going to have some good impacts to our actually regional and also global communities. Thank you very much for now.
Great. Thank you very much, Dr. Pimpa, for this interesting presentation. So yeah, sharing is the true spirit of battery swapping, right? So happy to share internationally today. That's one of the main reasons also for our event. Great. So we see for 2- and 3-wheelers, there's a lot going on. So now the big question is, does this also work, or is there any research or work going towards heavy-duty vehicles? And for that, we have got Mr. Hu from China SAE on board. So, Mr. Hu, I would like to hand over to you. Good afternoon. Yeah, we can hear you loud and clear. Maybe you could go on full screen in the presentation. That would be great.
Thank you. Good afternoon, everyone. I'm Hu Jinyong from China's Software Automotive Engineering. Today, I will give you a brief introduction, current situation, and the future development trend of battery swap network in China. I will introduce it to you in 3 parts. Introduction to battery swap, construction of battery swap network in China, future development trend of battery swap in China. First of all, let's take a look at what is battery swap. In fact, battery swap is the technology of replacing batteries. As the name suggests, it is to replace the power battery with more power on the electric vehicle. It's the same as changing the battery of a mobile phone a few years ago. Battery swap is divided into chassis battery swap, lateral battery swap, end battery swap, and top battery swap. Battery swap advantage. There are the following points. Buy a car without pedals. It takes only 3 minutes to make up the power quickly. No contact. High safety. Beneficial to the protection of batteries. Small impact on the power grid. Sustainable business operation model. Saving and efficient use of land resources. And conducive to the actual utilization of batteries. In recent years, China has issued a series of policies beneficial to the development of battery swap mode, which has well protected the development of battery swap in China. The conductor of battery swap network is beginning to take shape, and the car enterprises, battery manufacturers, large center enterprises and third-party service providers have joined in battery swap. In the past 2 years, the construction of battery swap station network has increased significantly. In terms of the construction of passenger car battery swap network, as of March 2022, 1,452 battery swap stations have been built in China, mainly distributed in the first and second tier cities and along the expressway, providing battery swap service for private cars and operating vehicles. In terms of the construction of heavy truck battery swap network, as of December 2021, 83 heavy truck battery swap networks have been built, with more than 45 million tabs of battery swap, more than 80 million kWh accumulated charging power, covering more than 50 cities. 6,000 vehicles in actual operation, more than 65 million kilometers of safety forms, and various heavy truck models covering more than 40 main engine plants. The future of China's battery swap is promising. In terms of technology development trend, the battery swap station supports the compatibility of multiple models, multi-brand sharing, standardized development of battery packs, cloud platform app sharing, standardization and integration of batteries, battery swap equipment and communication protocols, so as to realize the full size application of power generation, distribution, battery swap, and charging. Sorry. In terms of market development, with the continuous increase of the sales volume of new energy vehicles in China, the sales volume will reach 11.376 million in 2025, and the market penetration will exceed 35%. Whether it is heavy truck or passenger car, the demand for battery swap station will be greater. It is estimated that only 80,000 operating vehicles will need battery swap station in 2030. At that time, battery swap stations will blossom everywhere in China. Thank you. That's the end of my introduction. Thank you. Thank you for your attention.
Thank you so much, Mr. Hu, for your presentation. A lot of facts, a lot of data in that presentation, very interesting. That brings, let's say, on our excursion into battery swapping to an end. So we've seen 2 and 3-wheelers and then heavy duty and passenger vehicles from Mr. Hu now. And now we're going to go to, last but not least, to this nexus to the energy sector. So I think that's been mentioned previously. I think previously in the presentation, I think every presentation had a bit where we're talking about transformers, grid connection, or the energy demand in the countries. So now we're happy to have Professor Zakir with us, who will speak about grid integration and the use of renewable energy in the electric mobility sector. So I'm happy to hand over to you, Professor Zakir. I think you'll be sharing, right? Perfect.
Thank you, Stefan. Please confirm if you can hear me.
Yes, here, and we can see your presentation.
Great. Good morning, good afternoon, good evening, depending on where you are. So the previous presentations have touched upon different aspects of the electric mobility, primarily on the charging infrastructure battery swapping and conventional charging infrastructure that we have predominantly in place at the moment. In this presentation, I will try to take you through the interface between these EVs, EV chargers and the grid, and try to touch upon some of the challenges and issues that the grid actually experience or potentially can experience with this huge influx of the electric vehicle load that the grid had traditionally never imagined that this new set of load would come, and the grids across the world were not designed to cater this additional load that is coming to the shore of the electric grid. So therefore, it's important to have an understanding of what sort of charging infrastructure we are talking of, which to some extent the previous speakers already spoke about. But this slide is actually giving a glimpse of the type of chargers that are being added to the grid across the world. So if you can see that we started initially with this slow chargers, which made sense initially because we had EVs of low battery capacity. So therefore, the slow, what we call as low power chargers, were good enough to charge those electric vehicles without any additional, change in the existing grid infrastructure. But then, with the increasing penetration of electric vehicles and with the technology development in the batteries, the battery size of the electric vehicles has grown over the years. For example, we see cars, four-wheeler cars, having as high as 130, 135 kilowatt hour battery capacity against, in compared to 10 or 15 kilowatt hour few years ago. So therefore, the need for higher and higher capacity of the chargers is increasing. As you can see from this plot, we have these slow and fast chargers and rapid and ultra rapid chargers that are increasing rapidly across the world, particularly in the EV-rich countries. And we foresee, particularly in the public charging infrastructure, we'll have higher and higher power capacity chargers connect to the grid. If you take the recent infrastructure plan in across the countries, for example, in US, the requirement is that over these new plan of the charging stations is that the charging station should have minimum of 4 charging points, each of minimum capacity of 150 kilowatt DC, which means around 600 kilowatt minimum capacity of a charging station we are talking of there. Similarly, Germany has recently announced one of the initiative for the fast charging, where again they have 150 kilowatt capacity charging requirement for these fast chargers in Germany, and it is driven by the market. So therefore, this direction or the growth towards fast charging is happening, particularly in the public charging space across the world. But what does that mean to the grid is that it's going to be a significant load being added to the grid. So that means that grid needs to be actually planned, or the grid operation or the planning of this adding this infrastructure to the charging infrastructure to the grid needs to be carefully planned and accommodated in the grid. So coming to actually Indian statistics of the electric vehicles that we have at the moment, we of course are at the initial stage of EV adoption, but the action is towards adding more and more EVs actually rapidly happening across the country, both at the central level as well as the state level. We have little over 1 million BEVs at the moment, and which are predominantly two-wheelers and three-wheelers. But as I mentioned, we are adding more and more EVs as we move forward. We have various schemes and policies at the state level, and various schemes of adding electric vehicles at the central level. So If you see what are the impacts that I was talking on the distribution network, these can be classified in, broadly into different aspects. One is that we have this voltage issues in the grid that could actually be an issue because of this additional EV load. We have peak load can potentially increase if we are having uncontrolled charging. We can potentially have congestion of the feeders, the distribution feeders in the system, as well as increased power losses, power quality issues, reliability issues, and other aspects. I'm talking of only technical impacts on the grid here. Of course, there are economic side of it, those complications, cost complications, implications as well. So therefore, there's a range of these technical issues with the grid that need to be carefully, handled, and accordingly, the EV integration, EV charging infrastructure integration need to be planned according to the grid. So this is a glimpse of what are the different challenges depending on the location of this EV charger. So if it's a new home, it is relatively easy to handle it, but if it's an existing home, there is potentially a need for upgradation of the wiring or the cables that you would have there in the existing homes to accommodate EV charging load. On the street charging, you have potentially you can use the existing infrastructure for charging, but still there could be an additional infrastructure requirements. Workplace would essentially public charging workplace would essentially need at least some grid upgradation that could accommodate this EV charging load. So therefore, as you go for higher and higher power capacity charging stations, you would potentially need the grid upgradation if you are not planning the charging infrastructure or the operation of the charging infrastructure in an adequate manner. So this grid upgradation is a straightforward, simple to think of, but it has a think of a simple solution that one can potentially think from a technical point of view, but it has cost implications. So therefore, it becomes cost prohibitive in some cases, depending on the charging infrastructure you have and the penetration of the electric vehicles you have, utilization of the chargers, and all those additional factors. So what are the alternative ways to handle this additional load on the grid side is that we can have a smart charging, we can have a coordinated charging of the electric vehicles that could potentially, in some cases, avoid the need for grid upgradation, and in other cases, at least minimize or defer the need for upgradation of the grid. So therefore, there is a need for looking into the smart ways of charging these electric vehicles to address some of the issues that we try to highlight on the grid side. So these are different control applications that you can have. You can control the charging through the pricing mechanism, for example, time of day or time of use tariff, by having higher tariff at the peak load and lower tariff at the off-peak load hours, and that could potentially motivate the electric vehicle users to charge during the off-peak hours more. Then you can have V1G, that's smart charging for unidirectional chargers, where you have a control over the charging load, and you can have bidirectional V2G or G2V features in the EV chargers, which could not only help to influence or elevate the impacts on the grid, but also can potentially help the grid operator in managing the grid in a much better and more economical way. So therefore, there are different ways that you can control this charging load in the grid. And you can, as I mentioned, have different additional grid support services that this battery underlying with the grid, electric vehicles can help the grid to manage its grid operation. In India, when it comes to this infrastructure, we do not have at the moment in the market is compatible with V2G, and according to the bidirectional chargers, and infrastructure requirement of ICT and for V2X is also not adequately in place at the moment, and also energy market needs to be worked out. The other aspect is renewable energy integration. The basic purpose of this paradigm shift from conventional transportation to the electric mobility is the green transportation. But if we are ending up charging these electric vehicles from the conventional, these fossil fuel based power plants, then the basic purpose is actually defeated. So therefore, it is important that we have renewable energy based, charging of the electric vehicle load, and this helps in both ways. You can use the electric vehicle charging, to support the renewable energy integration in various ways. One of the example is here. In California, that they are addressing this duck curve, trying to address this duck curve issue in their grid by managing or controlling the charging of the electric vehicles. They can be complementary in nature. So the renewable energy integration can be co-located renewable energy based charging. It can be what we call in Indian power market open access, that one the load can actually purchase electricity from a renewable energy plant physically located somewhere else as well. So therefore, there is a need for increased renewable energy based charging of the electric vehicles. We did one case study where we actually found that with this renewable energy based charging can potentially be more profitable. It has higher NPV values, depending on various factors if you are targeting this renewable energy based charging. So before concluding, there are some relevant studies, these supported by JZ that we have carried out. We have some of the reports, 3 reports already published, which are available in the public domain, and there are 2 more reports that are coming up. This report 3, which is almost ready. I think we should be able to launch it within a month or so. And this report 4 on recommendation and way forward for seamless adoption of EV charging infrastructure in India is also going, we are expecting to have it ready for the public release in a couple of months. These are some conclusions. Conclusion is, fast charging seems to be the happening thing in the EV charging infrastructure, particularly in public charging space, which probably is inevitable. So therefore, it needs to be, embraced. However, we need to actually plan the grid side accordingly to accommodate this additional charging load, fast charging load. Distribution upgrade should not be seen as an untouchable activity in the grid, because we, particularly in the developing countries, because of the load growth, we do have upgradation of the grid. So therefore, wherever it is inevitable, potentially that should be considered. Smart charging should be one of the main focuses to have this coordinated control of the electric vehicle load to avoid this grid upgradation or minimize the grid upgradation. And there's a need to involve this electric vehicle with a controllable load more and more for supportive coordinated interaction with the grid. So with this, I would like to conclude my presentation and hand over back to Stefan. Over to you, Stefan. Thanks.
Thanks a lot, Professor Zakir. Very insightful presentation, a lot of detail. So I think this is really good to highlight that electric mobility isn't just purchasing this electric vehicle, purchasing the charger, but a lot is happening on the energy system side. We need to take this into account in all our endeavors in electric mobility. So I've been warned that we are over time already, so this questioning part unfortunately needs to be given up, but we are gathering all the questions in the chat and we'll answer them offline. So we won't leave you hanging. We're going to do this and upload it. I just wanted to highlight for you that we also gathered all the contact information from the projects and the speakers, and feel free to also address them directly or address our projects directly where we're working on these topics. And I hope, well, thanks to all the speakers. Firstly, this was great to have you on board and to go through this strict schedule. Maybe last thing, if the viewers' appetite has been triggered, we've also got, let me see, an event on battery ecosystems and recycling on Friday from our colleagues in India, Professor Zakir will also be part of this, of course. So if you're interested, feel free joining. This is a side event of the Transport Week. And without wasting any further minutes, thanks to all participants. I enjoyed it. I hope you got some ideas or got some interesting thoughts out of this session. I'm happy to hand over back to Kunpan in the studio.